These are the notes for AP Calculus on the topic of Maclaurin series. So Maclaurin series are a type of power series, and they're a special type of Taylor series. So Taylor series are the more general ones. Maclaurin is a type of that. Maclaurin series are specifically when they're centered at x equals 0, which oftentimes is the case, but not always. So if a function has derivatives of all orders at x equals 0, in other words, the derivative exists at x equals 0, all the derivatives exist at x equals 0, first derivative, second derivative, and so on, then the sum from n equals 0 to infinity of f, where this n here represents what derivative it is. So the nth derivative divided by n factorial times x to the n. And you can see it expanded out like this. So when you substitute in 0, it's f of 0. So it's the 0th derivative, just the original function, x to the 0 divided by 0 factorial. Recall that 0 factorial equals 1. And the next term would be f prime of 0, the first derivative at 0, x to the first, 1 factorial. Next one, f double prime of 0, x to the second, 2 factorial. It could be written on the numerator like this x, or off to the side, because this part's really the coefficient right here. And notice it keeps following that pattern. The third derivative at 0 divided by 3 factorial times x cubed, and then plus, and it keeps on going forever. So let's look at this first example. It says write the first 4 non-zero terms. So the terms that are not 0. Sometimes you get terms that equal 0 here, if the derivative or the original function equals 0. And the general term of the Maclaurin series for this, 1 over 1 minus x squared. So this here really represents our original function. So f of x here. And if we rewrite in a way that's easier to take the derivative of, notice we'll need the derivative in order to, first derivative, second derivative, third derivative, and so on, in order to substitute in 0. So f of x would be 1 minus x to the negative 2. Then we could avoid using the quotient rule as we take the derivative. All right, so let's first say we're going to need at least the first 3 derivatives, perhaps more, in order to get the first 4 non-zero terms. So there's our original function. Then if we take the first derivative, f prime of x, using the power rule and the chain rule, you'd bring the exponent down in front, so it would be negative 2, 1 minus x, reduce the exponent by 1 to the negative 3. But then the chain rule says we have to multiply by the derivative of the inside. The derivative of 1 is 0. The derivative of negative x is negative 1. So it gets multiplied by negative 1, making this a positive 2. Then the second derivative, f double prime x, we'd bring down negative 3 times 2 is negative 6, using the power rule. 1 minus x, subtract 1 from the exponent to the negative 4. Again, using the chain rule, times the derivative of the inside function. The derivative inside, again, is negative 1. When you multiply it by negative 1, again, this turns this into positive 6. And then the third derivative, f triple prime of x. Negative 4 times 6 is negative 24. 1 minus x to the negative 5 times, using the chain rule again, the derivative inside is again negative 1, making this multiplied by negative 1 a positive 24. All right, now let's look at what we're going to need for the first 4 non-zero terms. So here's our first term, f of 0, x to the 0 over 0 factorial, second term, and so on. So we're going to need f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. You could substitute those in right here, but let's go ahead and rewrite these so they're easier to work with without the negative exponent. So this one, as you can see up here, is the same as 1 over 1 minus x squared. The first derivative is the same as 2 over 1 minus x cubed. The second derivative is the same as 6 over 1 minus x to the 4th. And the third derivative is the same as 24 over 1 minus x to the 5th. So now let's go ahead and substitute in 0 into each of these. So f of 0 Well, if we substitute in 0, then that's going to be 1 minus 0 squared. That's just 1. 1 divided by 1, so that's 1. F prime of 0 is 2 over 1 minus 0 cubed. That's 1 cubed, so 2 over 1 is 2. F double prime of 0 would be 6 divided by 1 to the 4th is 1, so 6. And F triple prime of 0 is 24 over 1 to the 5th, so 24. So we can substitute this into our pattern here. So the first term is f of 0, which is 1, we just found, x to the 0 over 0 factorial, plus the second term is f prime of 0, which we found is 2, x to the second over 1 factorial, plus f double prime of 0, which we found is 6, x to the second over 2 factorial, plus, and notice the pattern is fairly easy to remember because everything here is the third derivative, x to the third, 3 factorial, and so on for each term there. So f triple prime of 0 we found is 24, x to the third over 3 factorial. So let's simplify each one of these. We'll first find the first 4 non-zero terms, and then we'll talk about what it means about the general term right here. Okay. So x to the 0, anything other than 0 to the 0 power, that's just 1. 0 factorial is 1, so this is 1 times 1 divided by 1, so the first term is just 1. Plus 1 factorial is 1, so that's just 2 divided by 1 is 2, so 2x squared is your second term. 2 factorial is 2 times 1, so 6 divided by 2 is 3, so we get 3x squared. Three factorial is 3 times 2, which is 6, so 24 divided by 6 is 4. And then we have x cubed. Plus, the way we can write the general term, we usually put a dot, dot, dot to show there could be other terms in between there. And then the general term, we just have to find the pattern. There's the first 4 non-zero terms. If any of these terms had turned out to be 0, we'd have to find additional terms to get the first 4 non-zero terms. In this case, we don't. So the general term we want to write, well, a formula basically like this that we can use to find any term in this Maclaurin series. So let's start with the x. So it'd be x to the, well, the first term has x to the 0, second term x to the first, and so on. So this would be x to the n, right? Whoops, what happened? I made a mistake, sorry. Sorry about that. I meant to write this as x to the first here. I made a mistake in my pattern. That was x to the first. I think I looked at this too and thought it was x squared. So this would be a 2x. Right? I could see by our pattern it wasn't working because these were both x squared, but I had made a mistake. So we have x to the n is 1, 2, and 3. And then notice, what's the pattern here? Well, this number is 1 bigger than our exponent. So how can we write that in terms of n? Well, since this is n, if it's 1 bigger than it, then the coefficient out in front would end up being n plus 1. So that represents our general term. So there's the first 4 non-zero terms and the general term of the Maclaurin series. All right, so sometimes you might have the actual function. Sometimes, though, they might give you information to find it in a different way, which is the case in this problem. So it says the function f has derivatives of all orders when x is between -1 and 1. And the derivatives satisfy the conditions below. So it says write the first 4, again, non-zero terms and the general term of the Maclaurin series. So the Maclaurin series is about x equals 0, so the derivatives are all going to exist there. So it gives us f of 0 is 0, f prime of 0 is -1, and then it gives us a formula we can use for the remaining ones, where n is greater than or equal to 2. So let's go ahead and find, again, we'll need at least to the third derivative, remember? At least to this one, maybe even further, to get the first 4 non-zero terms. All right, so following this pattern here, if we want f double prime of x, where this is 2. Another way to write it is with a 2 there. The second derivative, sorry, at 0, not at x. Well, following this pattern, it's going to be n. Well, notice if this is 2 right here, n would have to be 1 to make this 2, right? So n would be 1 times, n is 1 again, so f prime, or the first derivative, at 0. Well, we know f prime of 0 they give us is negative 1, so this would be 1 times negative 1, giving you negative 1. So there's f double prime of 0. We'll need at least the third derivative, so you can write f triple prime or put a 3 there with parentheses of 0. Well, this time, if this is 3, n must be 2 to make it 3, right? So n is 2, we plug it right there, times f, and if n is 2, this is the second derivative at 0. But we already found f double prime of 0 is negative 1, right? So this would be 2 times negative 1, gives you negative 2. Let's put it in our formula here. So again, the pattern here, remember, let's write it down here. So it would be f of 0, x to the 0 over 0 factorial, plus, next one would be f, the first derivative at 0, x to the first over 1 factorial, plus f double prime of 0, the second derivative of 0, x squared over 2 factorial, plus f triple prime of 0, x to the third over 3 factorial. All right, so let's simplify this. F of 0 we're given as 0. So this is 0 times x to the 0 is 1 over 1 factorial, which is, sorry, 0 factorial, which is 1. So 0 wipes that all out, so the first term here is 0. Well, we want the first 4 non-zero terms. This term is 0, so that's not going to count as one of our non-zero terms, is it? All right, let's look at the next one. F prime of 0 we're given as negative 1. So negative 1. X to the first over 1 factorial is 1. So our first non-zero term is actually negative x. And then f double prime of 0 we got was negative 1. So this is negative 1. X squared over 2 factorial is just 2 times 1, which is 2. So that'd be negative 1/2 x squared. There's our second non-zero term. F triple prime of 0 is negative 2 we found. So this is negative 2. X to the third over 3 factorial is 3 times 2 times 1. So the 2's reduce out here, notice. So you have negative 1/3 x cubed. So it looks like we're going to need one more term, aren't we, to get the first 4 non-zero terms, because this first term was 0. We only have the first 3 non-zero terms. Okay, so let's find the fourth derivative. Okay, so once you get beyond the third derivative to the fourth derivative, that's where you no longer put the little marks here. You just put which derivative is in parentheses. So that's the fourth derivative at 0. Well, if that's 4, using our formula, n would have to be 3. So it'd be 3 times, and this would be f triple prime of 0. So that'd be 3 times, we got f triple prime of 0 was negative 2. So that'd be negative 6. So if we look at the next term after this, the pattern would be the fourth derivative of the function at 0, x to the fourth over 4 factorial. All right, so we just got that that's equal to negative 6. Fourth derivative at 0. X to the fourth over 4 factorial is 4 times 3 times 2 times 1. So you can see what reduces here. The 3 times 2 is 6. That reduces out the 6. So we end up with negative 1/4 x to the fourth. And now we want the general term. So the formula that's going to give us any term we want in this series. So plus dot 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 plus, okay. And then To write the formula, well, let's start with the x part. So each time it's x to that power, the nth power. So for the general term, the x to the n. But this time, notice out in front, it's negative. So it'd be a negative 1 over, this is the same number as the exponent, isn't it? So negative 1 over n. There would be our general term. So now we've found the first 4 non-zero terms and the general term of the Maclaurin series. Okay, now let's look at ones where sometimes they may not ask you for the first 4 terms, sometimes it might be the first 3 terms or the general term. Sometimes they're just looking at a specific term, which is what we're going to see on the next one here. It says, what's the coefficient of the x squared in the Taylor series about x equals 0? Well, if it's a Taylor series about x equals 0, that means it's really a Maclaurin series. Sometimes they might refer to Maclaurin series as Taylor series, because they are, because that's a more general term. But if it's about x equals 0, it's really Maclaurin. So we've got 2 over 1 plus x squared. Well, let's think about our pattern. X squared, notice if we want the coefficient of that, that happens in this term, right, where it's the second derivative 0 over 2 factorial. So let's write that one down. So we've got f double prime of 0 x squared over 2 factorial. Well, if we want the coefficient of that, that means the constant out in front. That coefficient is talking about f double prime of 0 over 2 factorial. Notice that's going to always give you the coefficient of x squared. But we can get it more specifically because we can find the second derivative at 0 of this function. So again, since this is our original function, this is f of x. But to make it easier to take the derivative, we need the second derivative here. Let's rewrite this so we don't have to use the quotient rule. Again, the quotient rule wouldn't be wrong. It'd just take a little longer probably. So 2, 1 plus x to the negative 3. Utilize our negative exponents. And let's find, well, we need to get to the second derivative. Let's start with the first derivative, f prime of x. Negative 3 times 2 would be negative 6. 1 plus x to the negative 4th. F double prime of x. Negative 4 times negative 6. That would be 24. Notice using the chain rule here, it just multiplies by 1, so it doesn't affect it. So then 1 plus x to the negative 5th. So if we simplify that, that's 24 over 1 plus x to the 5th. And then if we plug in 0 into that, we get 24 over 1 plus 0 to the 5th. So that's just 1 to the 5th, so we get 24. So that's our f double prime of 0. We can put it right there. So we get 24 x squared over 2 factorial is just 2 times 1. So that reduces 24 over 2, reduces to 12. So the coefficient we're looking for of the x squared term is just 12. All right, let's take a look. A couple more here. This one's kind of similar, except the information is a little different. They give you the third function. F is a function with a third derivative given by this f triple prime of x. And we want the coefficient, again, of x to the 4th. So in the Taylor series about x equals 0. Again, if it's a Taylor series about x equals 0, it's really a Maclaurin series. Okay. So x to the 4th, well, let's follow that pattern. The term that's going to have x to the 4th has everything with a 4, right? It's going to be the 4th derivative at 0, x to the 4th over 4 factorial. But again, we want the coefficient, which is going to be this part of the term. That's what we're looking for. So we need the 4th derivative is 0. Now, if you start with the original function, we'd have to take the derivative 4 times. But notice they made it a little easier on us, or actually a lot easier, because they already gave us the third derivative. So we can rewrite that to make it easier to take the derivative. The third derivative is 1 plus 2x. Step to the square root of that. That's the same as raising it to the 1/2 power. And then we can take the derivative of the third derivative to get our 4th derivative. We'll bring down the 1/2, so it'd be 1/2 using the power rule 1 plus 2x to the negative 1/2. But then using the chain rule, we have to multiply by the derivative of the inside. The derivative of 1 is 0, derivative of 2x is 2, so times 2. And then notice what would simplify there. 1/2 and the 2. 2's reduced out. And then if we rewrite this in a simpler form without the negative exponent and switch it to radical form, it's going to be 1 over 1 plus 2x to the 1/2 is the same as the square root of 1 plus 2x. So now let's go ahead and substitute in 0 into that and see what we get. So fourth derivative at 0 would be 1 over the square root of 1 plus 2 times 0. Well, 2 times 0 is 0, so that's just 1 over the square root of 1. Well, that's 1 divided by 1, which is 1. So that's what would go right in here. So we'd have 1 x to the 4th over 4 factorial. So you could, the coefficient here, could be written like this. Whoops. Could be written as 1 over 4 factorial. That could be our answer. Sometimes you might see it written that way. But remember, that's the same as 4 factorial is 4 times 3 times 2 times 1, which is 1 over, that's 12 times 2, so 1 over 24. You can also see it written that way. 1 over 4 factorial, 1 over 24, both correct, just two different ways of writing it. Let's take a look at one more where we're focused on specific terms. This one's a little different, though, in that they actually give you the first 1, 2, 3, the first 4 non-zero terms and the general term for this Maclaurin series. Sometimes they might give it to you instead of asking for it, like the first two example problems. And what they ask you to find is, well, based on that, what's f prime of 0 and what's f double prime of 0? So again, knowing the pattern of the Maclaurin series is the key here. So let's start with the f prime of 0. Well, the f prime of 0, that's the first derivative. That would go with x to the first, and that would go with 1 factorial. So let's take a look. Where is our x to the first term? It's not there at all. So let's think logically what that would mean. No x to the first term. Well, what would cause there not to be an x to the first term? How could that be? Notice there's also not an x to the third term or an x to the fifth term. How could we have, why is there not a term there? Well, if you look, 1 factorial is 1, x to the first. The only way that can happen is if this f prime of 0 somehow wipes it out. And what would it have to be to wipe it out? Well, the only way it would wipe it out is if it was equal to 0. So because you don't see the term in there, that's what clues you in that f prime of 0 has to be 0. All right, now let's take a look at the f double prime of 0. Well, f double prime of 0, that's the second derivative. Whoops. That in the Maclaurin series pattern goes with x squared along with 2 factorial. So f double prime of 0, well, that goes with the x squared term. This time, though, there is an x squared term. If we look right here, that's this, right? So this has to equal negative x squared over 5 factorial, because this is the term that would give us that. So notice, based on that, to solve for f double prime of 0, these coefficients would have to be equal. Notice they both have x squared. So this, f double prime of 0 divided by 2 factorial, would have to equal negative 1 over 5 factorial in order for it to give you this term, right? They both have x squared. So let's go and write down what we have here. So logically, f double prime of 0 over 2 factorial is just 2 times 1 is 2, would have to equal negative 1 over 5 factorial. So to solve, we were trying to find f double prime of 0. To solve for that, since it's divided by 2, you would just have to multiply both sides by 2. So the 2's are reduced out there, so you'd get f double prime of 0 would have to equal, well, let's see, that's negative 2 over 5 factorial is 5 times 4 times 3 times 2 times 1. You can see what would reduce out there would be the 2's. So f double prime of 0 would have to equal negative 1 over 5 times 4 is 20 times 3 is 60. So it'd have to equal negative 1 over 60. And that concludes the notes for AP Calculus on the topic of Maclaurin series.